problem 914. This problem keeps coming in the exams, so you need to understand how to solve this problem. Okay, something like this will come in the exam. So you are provided with the following information about a municipal wastewater treatment plant. This plant uses the traditional activated sludge process. So this will let you use the traditional activated sludge process equations. Assume that the microorganisms are 55% efficient at converting food to biomass. Okay, that is yield. The organisms have a first order death rate. You have KD 0.05, and the microbes reach half of their maximum growth rate when the BOD concentration is 10. That's KS. There are 150,000 people in the community. Their wastewater is 225 liters per day per capita. Per capita mean humans. 0.1 kilogram BOD5 per capita per day. The effluent standard is, the effluent mean the things leaving the plant is 20 milligram per liter for BOD5 and 20 milligram per liter of total suspended solid. Suspended solids were measured at 4,300 milligram per liter. That's inside the aeration tank. And the wastewater sample obtained from the biological reactor, which is the aeration tank. 15,000 milligram per liter in the secondary sludge. This is the concentration of the sludge coming up the secondary sludge. 200 milligram per liter in the plant influent. Okay. And 100 milligram per liter in the primary clarifier effluent. So 200 into the primary, 100 out of the primary, 100 lost in the primary clarifier as sludge. SRT is 4 days. Let's look at the first part. What is the design volume of this aeration basin in meter cubic in meter cubic? Okay. Remember the equation that we should follow in order to find out the volume. Okay, so the SRT, so we should do it like that. Okay, so this one, first of all, we have, let's finish the first part. We have 150,000 people. Okay, or let's call it capita. Capita mean people. Times, remember he gave you 225 production, wastewater production. 225 liter per capita per day. So capita, people with people, cancelled. So now you have liter per day. So if you multiply this times this, you will end up with the same number. Remember the same number? But here in this example, it will show you how to get the number you have in the notes. 33.75, 10 to the 6 liter per day. Okay. The BOD influent is also not given. So let's find the BOD influent. So 150,000, this is flow. 150,000 capita times, he gave you the BOD N is 0.1 times 0.1 kilogram BOD5 per capita per day. Capita with capita. Now you have kilogram per day. So this is kilogram per day. So now this is kilogram per day, so you'll have it as, this is the BOD influent, this is BOD influent loading because it is in kilogram per day. So this is 1,150 00. So this is kilogram per day. So now you have the loading. How could you find the actual BOD5 getting in? So remember, the loading is equal flow times what? Times concentration. So this is the loading. So the loading is 15,000 kilogram per day, and that is loading. Q is what? What's the flow rate? The flow rate is 3,375 10 to the 6 liter per day, and that's Q, that's liter. And you should make this, because kilogram times milligram per liter, and this is X. So day will cancel with day. Liter will cancel with liter. Milligram will not cancel with milligram. So we have to put it milligram, kilogram. So 1 kilogram is 10 to the 6. So now 10 to the 6, 10 to the 6. So now you have X okay, 15,000 over 33.75. 15,000 of 33.75, and I think that's it. Okay, so okay, I think that's it. This would give you BOD in milligram per liter, 444. This is the same thing that you have in your notes, but you see how is this problem try to transfer you from raw data to the BOD5 influent. So this is BOD influent in milligram per liter. Okay. So now we should also assume the following assumption. SRT is 4 days. Okay. Also, we are assuming that 30% of incoming BOD is removed in the primary treatment. So 30% of BOD is removed in primary tank, and 70% is coming to the aeration tank. Also, when he said in the things 55% efficient in converting food to biomass, this means that the yield is 0.55, 55%, 55 over 100. So the yield is 0.55 gram suspended solid over gram BOD. Of course, it has a death rate of KD 0.05, and also we put the equation now. You should go and look at the equation in the notes. So I'll try to put it here. Okay, I'll try to follow up the numbers that we have in the notes. 1 over SRT. SRT is 4. Equal. Okay, what is the flow? Remember the flow, it was given 33.75, 10 to the 6. liter per day. Okay, remember there was something close to it. The yield 0.55 grams suspended solid over gram BOD over the volume. That's what he needs, the volume, over X the biomass content inside the aeration tank, 4,300 milligram SS over liter times. Now, the influent BOD coming into the aeration tank is 70% of the initial, because 30% will be going inside the primary tank. Remember the primary tank? Let's do it like this here. This is the primary tank. And what was the BOD in? It's 444 milligram per liter. 30% of this gonna be settled down. It will be removed. So let's look at this. 30% of 444. So 133.2 milligram per liter will be removed here. The rest will be going toward the aeration tank. So minus 444, and this would give you almost 311 milligram per liter of BOD entering. You could multiply 70% times 444, and that would give you the same thing. Okay. So this is 300. What is it? 311 minus, what is BOD out? Not the aeration tank. Oh. Leaving out here the BOD, he said that it should not be more than 20. And this is minus KD 0.05. Of course, the whole thing here is milligram per liter. Okay, 0.05 per day. So you find the volume to be equal to 4.2 10 to the 6 liter. So now we are finished from the first part, the volume. Now let's find out the next part. Okay, let's clean up. Okay, let's look at number B. Number B, he's asking for what is the plant aeration period. Okay, so the detention time, or the hydraulic detention time, or the period, is equal volume over Q. We just found the volume. 4.2 10 to the 6 liter. And the charge equal 33.75 10 to the 6 liter per day. And this would give you 0.12 days and 2.9 hours. Let's look at the next one. C. How many kilograms of secondary dry solids need to be processed daily from the treatment plant? So now he wants to know how much sludge is being produced from the secondary. So here, remember, some of the sludge will be recycled back to the... Oh, no, not this one. Some of the sludge will be recycled from the settling tank back to the aeration tank, and some will be wasted here. So he needs to know how much is wasted from the secondary settling tank. So here we have to use the equation that we showed you in the notes, that SRT what is relate how much wasting is SRT. SRT is equal volume X over QW XW, and how much wasted is XW QW Vx over SRT. The volume is equal 4.2 10 to the 6 liter, and the concentration of the bacteria is 4,300 milligram SS per liter, and SRT is 4 days. So QW times XW, if you multiply, this is going to be liter with liter. You will end up with milligram SS. Okay, you need to convert this milligram to kilogram. Milligram to kilogram. 1 kilogram is 10 to the 6. So this is divided by 10 to the 6. You'll end up with QW XW 4,515 kilogram per day. Almost 4.5 tons per day. That's a lot. Okay, let's look at the next problem. D. If the sludge wasted rate, QW, is increased in the plant. Okay, let's take this, clean it up, and look right now the relationship. If the sludge wasted, QW is increased. If QW is increased in the plant, will the solid retention time goes up, down, or remain the same? Well, let's put the equation. If this is QW increase, what will happen to SRT? Of course, there is an inverse relationship. SRT will decrease. SRT will decrease. Sometimes I will tell you the following. Of course, I'm not going to be stuck with this. If XW, the microbial content in the aeration tank, increase, what will happen to SRT? Also decrease. If it is decreased, SRT increase. So you should know if it's inversely proportional or directly proportional. Okay? Okay, so let's find out the next one. Determine the F over M ratio in units of kilogram, BOD5 per kilogram, MLVSS per day. Okay, he need to know the F over M. This is this one was D, and this one is E. E, F over M. Q naught S naught X V. What is Q naught? Q naught 33.75 10 to the 6 liter per day, and S naught. Well, now we will be dealing with the S naught entering the aeration tank, not the initial influent coming to the primary tank. No. So we will have 311. I think that's what we calculated here. 311. So 311, which is 70% of 444 milligram per liter, divided by X, 4,300 milligram per liter, SS, and of course, now this 4,300, as we mentioned here, we did not put it there, but let's say what was the requirement that he put here? That's solids and 40,000 with water, okay, 200 milligram. So it's only 70-30. Okay. So you have to multiply it by, because not all of this as an X. This is milligram suspended solid, but he wanted an MLVSS. So the volatilized suspended solid out of the total will be 60%. So you have to multiply this by 0.6. This will be given. You don't have to assume it 0.6, 0.7, and 0.5. Most of the time it's 0.7, but it will be, as the book put 0.6, we will take 0.6. 60% of the total suspended solid is volatilized, and he wanted in VSS. So you multiply it by 0.6, and that's multiplied by the volume, 4.2, 10 to the 6 liter, and that would give you 0.97. 0.97 is a huge food over microorganism ratio. So this is in kilogram. Well, this is milligram over milligram, which will be cancelling out. It's kilogram BOD 5 over kilogram MLVSS day. Milligram over milligram will give you the same thing, kilogram for kilogram. You could cancel it both to kilogram per kilogram, it will give you the same answers. Of course, liter by liter and liter by liter, so you'll end up with kilogram over kilogram per day, because the day is here. So this is 0.97. 0.97 is still huge. Okay, so let's erase the last one and solve. Okay, oh, let's look at draw. Okay, so the last one, what is the mean cell residence time? He need to know the mean cell residence time. Well, it's the same thing, mean cell residence time and sludge retention time is the same. So the mean is equal SRT. SRT, sludge retention time, solid retention time, and mean cell residence time is the same. So this is equal to 4 days. Thank you.